Hi everyone, my name is Beth and I'm here to tell you about my job as a research scientist at the National Physical Laboratory. But before I tell you all about my job, I wanted to share what I was like when I was in primary school. When I was 10, my favourite lesson was definitely art because I liked being creative. I was probably best at maths and science. My worst subjects were definitely spelling and PE. I'm still not great at spelling today. My hobbies were dancing. I went to ballet lessons every week and I got to grade 8. I also loved Playmobil and had loads of sets. I also liked Harry Potter, visiting the beach and salt and vinegar crisps. Afterwards, I worked hard at secondary school and then went to university. I studied a mixture of chemistry and physics, but I also had a really fun time and met some really good friends there. I graduated and since then I've had the opportunity to work on some really cool experiments. And also I get to talk to people like you about science. I've even picked up a couple of prizes for things I've presented. So now you know a little bit about me, how about I tell you a little bit about my job? I work in STEM. That stands for Science, Technology, Engineering and Maths. So I'll explain a little bit about what those words mean. Science is all about explaining what happens in the world around us. From the really big questions like, why is the sky blue? To everyday questions like, why does the ice in my drink melt? Technology is about assisting us in our everyday lives. Most people have phones now that help us communicate, navigate, learn, and even keep us entertained. Engineering is about automation and using machines to help us. Think of a production line as an example. It helps us manufacture things in a much more efficient way. Even fixing your bike is an example of engineering. Finally, maths is all about amounts. Without maths, we wouldn't be able to keep track of things, so we wouldn't be able to do things like baking a cake. And without maths, parts of machines wouldn't fit together, so we wouldn't have useful things like cars. You can think of maths a bit like a language that we use so that we all understand each other. I'm not alone in working in science, technology, engineering or maths. There are about 5 million of us in the UK. It's a really exciting thing to be a part of. I work at the National Physical Laboratory. That's our logo there in the top right. You may not have heard of it, but it's the UK's National Metrology Institute. This means that we make measurements that help the whole of the UK. Our measurements help provide confidence that the things we buy live up to their claims, that the medicines we take are the right dosage, and that the data we use for everything, from climate change to financial trading, is accurate. The pictures on the slides show our main building in London, where I work. One is of the outside, and the other picture is of our bright and colourful reception. This building has 400 science laboratories, so there's always loads of interesting work going on. We have groups that research medical physics, time, materials, the environment, and loads of other things too. I work in the Surface Technology Group, and our job is to measure the physical and chemical properties of surfaces, ranging from biological samples to electronic components. I spend most of my time measuring particles. Particles are everywhere. There are just a few examples on this slide. Lots of medicines that people take are powders that are made into tablets. And it's important we know how the powder will react in the body so that everyone can be sure that their medicine is safe. The size of particles in coffee is also really important. For the best tasting coffee, you want a mixture of small, fine particles and bigger, coarser particles. Particles can also help us power supercars if we add particles as additives to fuel. Something most of you will be familiar with is sunscreen. Even though we can't see them, a lot of sunscreens use particles to reflect the harmful UV away from our skin and keep us safe. Even display screens use liquid crystals. Finally, particles can be important in medicine. They could help us deliver medicines to the right parts of the body. The great news is that we can measure loads of different characteristics of these particles to help us understand them a bit better. This includes particle size, shape, density, surface area, charge, and we can even measure components of complex mixtures too. So let's have a go at a real thought experiment. I'm going to share part of a talk that I gave to real scientists and that I won a prize for. So it's time for you to think like a scientist. We are going to think about measuring muesli. I would like everyone to think of a box of muesli. Muesli is just a mixture of breakfast things like oats, some dried fruit, seeds, and maybe some nuts. You can put whatever you like into your muesli. Let's imagine our muesli is in a dark box, so we can't see what's inside. How do you think a scientist would measure what's inside? We could use some of our amazing technology to measure the whole box. But the problem is it would take a really long time, and we wouldn't have any breakfast left for tomorrow. Instead, we might decide to measure a single spoonful of muesli. But if we want to do that, we need to first think about some questions. The first one is, how big does our spoonful need to be? Or how much sample do we need to measure? If we look at the picture on the top, you can see that the spoon contains some oats and some of this red fruit. But the spoon doesn't contain any of the green seeds in the front of the picture. This is a problem because if we only measure what's on the spoon, we might think our muesli has no seeds in it at all. But that's not true. This spoon is obviously too small. We also need to think about where to take our spoonful from. If any of you have eaten cereal, you'll know that the last bowl in the bottom of the packet is all dusty. And I'm going to show you why. We're going to watch a little animation now, but I'll start quite quickly, so pay attention. The animation showed us that as we vibrated the box, the big bits ended up at the top and the little bits have ended up at the bottom. This is exactly what happens to our box of muesli when we shake or vibrate it. For example, when it's on the lorry going to the supermarket, or when we take it in and out of the cupboard at home. In fact, scientists even call this the Muesli effect. By doing experiments and making models using maths, scientists have been able to understand these effects a lot better. And now I use that knowledge when I design my experiments. So let's take a look at what I do in my lab. Here are some pictures of me at work. I'm wearing a lab coat and some goggles and some gloves, which are really important to keep me safe. And the box just behind me is a real scientific instrument containing a laser for measuring particles. Part of my job is working out how to measure very small particles. I've measured gold and silver, plastics and even food. Just like the muesli example, I have to be very careful about mixing the powders first and taking a big enough sample so that I don't miss anything. There are other people at NPL that do similar measurements. We collaborate and share our knowledge so that we can all get better at measuring. Finally, the most exciting thing is when we work with companies to tell them things they don't know or to test brand new things that they've just invented. I've told you what kind of measurements I do. Now I'm going to briefly explain why they're important. Because particles are everywhere, lots of people benefit when we measure them. Everyone, young and old, benefits from healthcare and medicines. Measurements are really important to make sure that they are safe. If you play sport, you might use equipment made from composite materials, like this lightweight tennis racket here. These materials wouldn't exist without scientists. I mentioned that I measure food. Well, we can use this knowledge to make food taste even better. And it's not just people, the environment will benefit too. Microplastics are often in the news because they get into the ocean and can harm sea life and birds. If we can understand more about how plastic particles behave, then we can help to stop this happening. When I'm at work, I use STEM all the time. I use my scientific knowledge to design experiments, to learn from other scientists around me, and to publish my results. That last one is really important because you want other scientists to learn about your work and maybe even be able to repeat it too. I use technology when I do my measurements, including software, microscopes and lasers. I sometimes have to use engineering to keep an instrument working well or to change the setup of my experiment. And of course, I have to use maths to do calculations and to present my results in a way that everyone can understand. So now you know what I do, I wanted to tell you what I enjoy about my job. I really like that I get to learn something new every day. It's never boring. I also like being able to make a difference by solving problems and making measurements. But by far the best thing for me is that I get to work with some really great people. I get to work with men and women from all over the world who are fantastic scientists, and I get to discuss my ideas with them. Now, of course, every job has its challenges. The biggest challenge for me is when my experiments take a really long time or don't work. It's really frustrating, like getting to the end of your homework and then realising that you read the question wrong and you have to start everything all over again. I also have to do lots of reading and writing sometimes, which means I can't always be in the lab. Another big problem for me is finding a lab coat that fits. I'm only 160 centimetres tall, or 5'3". So when I was at university, I ended up with this big lab coat with sleeves that went right down to my fingertips, and accidentally knocked a glass beaker off the lab bench. Fortunately, no one minded too much, but they did make me wash up some beakers as payback. And since then, I've always made sure I have a lab coat that fits. So now you know what it's like to work in STEM. I just wanted to finish off by talking about how you can be a scientist too. Everyone can be a scientist. It doesn't matter where you come from or what you look like. In fact, the best science happens when we have lots of different people working together. And you already started thinking like a scientist today, when you thought about your muesli and the measurement problems that you might come across. To be a scientist, you need to stay curious and ask questions. You also need to work hard at school, especially at maths, which can be a bit hard, but your teachers can help you. And if you want to get started right away, you should definitely try some of our measurements at home challenges. It's really fun, and it's real science, just without the lab. Although I would probably check with an adult before you use all the toilet paper to measure the speed of sound. Well, that's everything from me. Thank you so much for listening. I've really enjoyed telling you what my job is like as a research scientist at the National Physical Laboratory.